All right, so we were just asking what it means to intersect or intercept something, which are pretty much exchangeable. By the way, homework's 14.5 and probably 14.6. So what's that mean? Seth?
Like line-wise, or just
in general?
When two things come across and meet at one point.
Yeah, where two things meet, it's the point at where they meet. Anybody have any other definition for this? Pranav?
When they cross paths.
When they cross paths? Yeah, a lot of times. Now, it doesn't necessarily have to cross. That's one thing that confuses a lot of people. My line can start there, and it still counts as the intersect or the intercept. So here, each of our plants, we talked about our plant competition last time we met, each of my plants, when I bought it, started at a certain height. So the first time I saw the plant, it had a height already. So these values right here, 6, 4, and 2, those are my respective y-intercepts for those lines. So all it takes for us to identify the y-intercept of a line is to look at where that line crosses the y-axis. And if we have the equation of the line, it's even easier. Because as you guys saw in science, once we start looking at the equation, the y-intercept is just that extra number added or subtracted. So here, I cross at 0, intercept is 0. Here I cross at 4, intercept is 4. Here, I cross at -3, the intercept is -3. Any questions on this?
It's not that hard. So why didn't we just do the one when it crossed right there from the beginning for the last one?
You need to be a little bit more detailed. Why didn't we do the one right there on the last one? I don't know what you're trying to ask.
When you're going from the first coordinate to the fourth one, how come we didn't go from
Can you come up here and reference what you're actually?
What's the y?
We're talking about we're not talking about slope right now. We're just talking about y-intercept.
So on the last.
This one?
He was thinking of the x-axis right here. Why wouldn't you use that one?
Yeah, that's the x-intercept. We're only talking about y-intercepts. Okay, we don't care about x-intercepts right now. So, only the vertical axis. What we care is where we cross the vertical axis. So good to get that confusion out of the way. So, if we look at, actually I'm just going to check what your notes have. If we're given the equation now, y equals x plus 3. Anyone know what the y-intercept is in that equation? What if I come back up here and tell you that the equation of this line would be y equals 1/2 plus 0? It will. What if I tell you that on my second line there, it's y equals -x plus 4? James? Sorry, you had your hand up. I thought you maybe had something. They're smarting. So this equation, and if I was you, I would write it, is y equals 1/2 x plus 0, but we don't really need the plus 0. My next equation, though, would be y equals -x plus 4. Peyton, you had your hand up.
Does that mean for the example would be 3?
Yeah. So this, you need notes, Baylor? They're here for today.
These are, this
5?
is 14.6.
Yeah, we're on 5. So, check out here to the right of the graph. The coefficient of the x tells us the slope. So what's the slope here in the the example, sorry? What's the coefficient of the x? What's coefficient mean again? Shahid?
The number with the variable.
The number attached to the variable through multiplication. It's the number multiplied by our variable. What number is multiplied by our x here? 1. Our coefficient here is 1. Our slope is 1. When we don't see a coefficient, we know that there's actually just a 1. So for some of you, it would probably help to write the 1 in front of the x. This goes on to say the value of the constant tells us the y-intercept. So here, well, what's the constant involved in my equation? Karen? 3. So my y-intercept is just 3. So when I start making this graph, I start with a point on 3. Now, based off my slope being 1, I don't want to slide over, make sure I'm not missing things. Start replacing the point with the y-intercept, then we move according to slope. I'm just going to keep this over here, and I'm going to write my equation up here. Y equals x plus 3. Got a 1 and a 3. So we start by placing a point on the y-intercept. So everybody should have their point on 3. We good? Got a point on the y-axis of 3. Then, how do I know what my rise or my vertical movement and my run, my horizontal movement, how do I know what those are? Olivia?
The 1 and the 3.
Not the 1 and the 3. The 3 we've used, we're done with it. Once I place my point at the y-intercept, we're done with the 3. I cannot use it again. No?
The coefficient of the x tells us the slope.
The slope is 1, which if I think of in rise over run form, it's really 1 over 1. So I'm going to do a vertical movement of 1 and a horizontal movement of 1 to get to my next point. So I go up 1 over 1, boom. 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 Once I have enough to connect and make my line, I can just make my line. I could also, though, go down 1, left 1, because a negative 1 over a negative 1 would also give me a 1. So if I go from that point down 1 over 1, there's my point. Down 1 over 1, there's my point. Down 1 over 1, there's my point. So the line continues the other direction as well. You don't have to switch colors. I did it just so that you can reference in the notes what I was doing and why. No?
So the x point is -3?
Yep, the x-intercept would be -3, but we don't really care about the x-intercepts right now. Yeah, just where we start, we a lot of times just go from the y-axis to the right. So when you're asked for the y-intercept, all you have to do is look for that constant value added or subtracted. So when I look at my got it, y equals x plus 6, what is my y-intercept? Oh, you just had an answer. Peyton. 6. It's just the constant value added or subtracted. So your y, and we abbreviate this with y-int, is 6. Or you can give the point x equals 0, y equals 6, because at the y-intercept, your x is 0. I want you to try this next example on your own. For situations A, B, C, and D, determine what the y-intercept is. You've got 2 graphs, 2 equations. Gravity always works. Good question. Ashton, what'd you get for the y-intercept of the first graph there? -2 is absolutely correct. The y-intercept for my second graph, Jackson?
2.
+2. The y-intercept, Noah, for C. -3. Like we've said all year, the sign in front of a term goes with the term.
For the absence.
So I could actually write this as y equals 4x plus a -3 but that's kind of annoying to write like that, so we normally just write the minus 3. And Lily, for D, my y-intercept
3.
is 3. Any questions, comments, or concerns on any of those?
So the intercept is the constant, right?
It's always the constant, yep.
Okay.
So when we look at the graph, we can easily find where the line crosses the y-axis, but when we are given the y equals mx plus b form, this is called, so this form of an equation, y equals mx plus b, did you guys learn this in science, what it's actually called? Called blank blank form. What does the m value tell you? Tells you the what of the line?
The slope.
The slope. What does the b value tell you?
Oh, that's
Noah?
The y point?
Close.
The
Intercept. So this is called a slope-intercept form. When we write an equation like this, it is slope-intercept form because m is the slope and the value of b is the y-intercept. I should have probably turned my structure of that sentence around to first ask you what the m and the b were. Now here's a good question. Does the slope affect the y-intercept? Does this being negative 5 have an effect on my y-intercept? Nate?
No, because the last two questions we had didn't affect it.
Yeah,
at all.
you think about this 4, this negative 4, they don't matter. The slope does not relate to the y-intercept. The y-intercept tells me where I start. The slope tells me how to move. So the y-intercept is just a point. The slope tells me how I move. So in this got it, Mr. Boyer, what is my y-intercept? -1. And for the bonus points, what is the slope? -5. My y-intercept is -1. My slope is -5. We know everything. Now, really, when we go to write that, I'd go -5 over 1 because, like we said, we like it in fraction form. We like to know that this would be my vertical change and this would be my horizontal change.
See, I feel like I'm overthinking it, like completely.
Your friend always likes to talk a lot, apparently, says that every linear equation must cross the y-axis. Provide a counter example to your friend's statement. So if it doesn't cross the y-axis, Karen? But what kind of, so how would I write that though? So what sort of line would that be if it only crosses the x-axis? Well, yeah, every line, anything that's really a line is straight. But Karen, how would the line look? How would you describe it if you were talking to somebody? It'd be a vertical line. But now the question is, how do we write the equation of a vertical line? Shahib, because your card's up.
It's 0.
What if I wanted a vertical line at say I wanted a vertical line right here. And we'll say that is the x value of 5. Noah?
5 over 0.
No. Because we cannot divide by 0.
Well,
Absolutely no way.
It's an indeterminate.
Yeah, but I'm not going to write an equation using an undefined value. That would be messy. Olivia?
0 over 5.
Because there is rise. There's a whole lot of rise. There's a ton of vertical change. Nate?
When you use fractions?
Nope. Karen? We cannot express this slope. It's impossible to express this slope.
Oh, yeah, 'cause
So
it's
we
infinity.
don't want to write it in slope-intercept form.
Because it can just keep going.
Because there is no intercept.
Yeah.
And there is no definable slope. So slope-intercept form is right out the window. What's your x value here?
5.
What's your x value here?
5.
What's your x value here?
5. This is a 5.
That's your equation. Any vertical line is just x equals wherever it is. So a vertical line out here, maybe we do that at like -3. That would be x equals -3. So we do not use y at all because y is going to change. But x is always that value. -3, 5, whatever the equation, x is always going to be that value. So for vertical lines, it's always an x equals equation. Because my y is constantly changing. For now?
So if we had it horizontal, the slope wouldn't that be 0 then?
Yes.
But
So this is a totally different question, but let's say we had a horizontal line, snow on the ground. We started the week with 8 inches of snow, and we've gotten no more snow.
what would be the y-intercept?
Well, what is the y-intercept?
8?
8. Is there any slope?
No.
So that would be y equals 8.
Oh.
Like a vertical line is x equals, a horizontal line is y equals. Because my y value is always 8. It's never changing.
So you
And my slope is 0, so this is really y equals 0x plus 8, but 0 times anything makes it 0, wipes it out. My plus 8, just 8.
So you can't find a y-intercept for
A vertical line,
Yeah.
you cannot find a y-intercept, but a horizontal line has to cross the y-axis somewhere. And where it crosses the y-axis tells me what the equation is.
What would be the equation for just like a line on the line or
Well, what's the x value?
or x equals?
Is it vertical?
Yeah.
Then it's got to be an x equals, and if it's at 0, x equals 0.
what happens if it's a ray? Like it doesn't go from both sides.
What I just drew is a ray. If I start my data right now, and there's 8 inches of snow on the ground, I don't care about the past. I don't care about how much snow there was. I care about starting now, moving forward. So that's fine. It's still a line. It's not a continuous line. It only continues out in one direction, but that's fine.
So if we didn't start off there, if we started off like in the middle somewhere, it would
That's
still-
impossible. You cannot start collecting data 3 days after you started. You know what I mean?
Yeah.
You cannot start something after you started it. Like, that doesn't make any sense. So I like that you're trying to like, ooh, can we trip him up? Can we find something? Like, I like all your questions, but that's just an irrational. You can't, like, my line can't start like here. That doesn't make any sense. I'm gonna start collecting data on day 3. Well, what happened to days 1 and 2? Like, come on, where'd they go? All right, so let's model this. Now, unfortunately, we've had barely any snow this winter. But let's say we do get a snowstorm. And when we leave school, we've got 3 inches of snow on the ground. And you guys are so excited. You're like, you know what? I'm going to collect some math about this snowstorm. Because that's how cool you are.
Yeah.
So you go, when you get home, 3 inches of snow on the ground. We'll say that between like leaving school and home, there was a time paradox and you immediately got there. So after 1 hour, you walk outside with your handy dandy ruler, you measure, and now there's 4 inches. Or sorry, after 2 hours. So after 1 hour when you walked outside, there was only a ½ inch change. Not very much, not much measurable. But after 2 hours, we've got a whole inch. You wait another 2 hours, and we get another inch. In another 2 hours, we get another inch. So if I want to represent this in an equation, I first need to figure out the slope and the y-intercept. It doesn't matter what you figure out first. If you're like, well, what do I do first? I do the y-intercept first because it's easy. So when I think about my y-intercept, where's my y cross, or where's my line cross the y-axis, James? Huh? At what number does my line cross? Yeah. So my y-intercept is 3. My slope then is, remember, delta y over delta x So I go point to point, and I'm going to do a long one. When we went to bed, we stayed up real late till 11 o'clock at night. Let's say you got home at 5 o'clock, stayed up 6 hours, and we now have 6 inches of snow. Between when I got home and when I went to bed, what was my vertical change? 3. What was my horizontal change? 6. So my vertical change over my horizontal change, really, it's 1/2. So we are getting 1/2 inch per, no, that's per 1 hour. Because remember, if I went up just to my 1 over, that'd be a 1/2. Every time I go 1 over, I'm only going a 1/2 up. So now my equation, hang on to it for a second. Now my equation becomes y equals my slope times the x plus my y-intercept. Now, questions. Nate?
I just have a comment.
Okay.
You know how like the news makes like everything like they always say like, oh we're getting 6 inches of snow overnight, but it's only 6 inches. They make it sound so big. And
Well, it
so,
depends on people's, like,
so
certain
much.
towns have better snow removal than other towns. We're really fortunate around Worthington, Columbus. They're pretty good at plowing the roads. Like out in Coshocton, if we got 6 inches, we don't have enough plow trucks to deal with all the roads, like, because it's a big county with a low population. We only have like 11,000 people in the whole county, where we probably have that in, Worthington alone. Probably more than that, actually. So it's all contingent, and you got to realize news stations cover big areas.
Yeah.
So like the NBC4 you watch over here, it's the same NBC4 my parents are watching. So when they're like saying, "Hey, here's your warning, we're getting 4 inches of snow," well, it's only 4 inches, but for them, that's a pretty big deal. So yeah, I understand what you're saying, but it's all relative.
Yeah.
That's one of those things where you hate it, but it's all relative.
Like if you live out in the country, like 3 inches of snow is like no.
If you have a car, yeah, you might not be able to get through it. Now, if you have like a truck or something 4-wheel drive, you might be okay. Try this on your own. I want you to write out the equation of this line and think about what it actually represents. And if you read the situation, it will make sense. But on your master, you're going to be asked to like talk about what this means. So this one, it gives you the situation. It kind of makes sense. But think about if you just had the graph and the labels on the graph, so dish soap and hours, would you be able to think, oh, that represents what it actually says up there?
At what time do you run out of coffee? Because it always seems like we have an evening supply of coffee.
It does.
It's a very good question.
My super beer has like a coffee question.
Yeah, but I don't really drink coffee after lunch. Well, if I have some left, I do. But I drink 1 mug a day. That's it.
My dad drinks a lot.
Dad's also under a lot of stress, I'm sure. When we look at the Y-intercept here, Rye, what do you get?
6.
6. And what does that actually mean?
That means 6 ounces.
What has 6 ounces?
The amount that it leaks. Is that?
That's 6. And this is like when you were asking about a ray. Here I have a segment. I don't even have a line like continuous. I just have a segment showing. This is still fine. It's still a linear graph. What's it mean, Peyton?
It's how much dish soap is in the bottle. Like a
Means we have 6 ounces to start.
That's literally what I wrote.
That's where my line starts. That's where our situation begins. We have 6 ounces to start. We're 6 ounces at time 0, which normally that's when we start. So then, what is my rate of change or my slope here? Come on. Between people being sick. Zach, feel better. Hopefully you're watching this. Grace, do you know what our slope is?
It's 1.
What's our vertical change? You're really close. To go from here to here, what's our vertical change? Somebody help her out. Olivia?
-1.
We're going down. It's -1. So my slope is actually -1. What does that mean, though? A slope of -1 here is telling me.
That you're losing.
Be more specific. Losing.
This.
Don't just say soap.
Ounces.
How many?
Oh, -1 ounces.
So I've taken care of the negative by saying losing. So we're losing 1 ounce.
For 3 hours.
Yeah, losing 1 ounce every 3 hours. Now wait a minute. So my delta x, I wrote 1 because it's 1 box, but is 1 box actually 1? My delta x, my change right here, how far I went. How far was that? 3. So my slope should not be -1 over 1. It should be -1 over 3. I was waiting for somebody to catch it. It's 1 box, but that 1 box is worth 3 hours. So my slope is actually -1/3. And you can put the negative on top, bottom, or out front. When I write this equation, I write -1/3 x plus 6. You got to be really careful with those slopes when the x values don't change by 1. Got to be really careful with those slopes when the x values don't change by 1. Are there any questions, comments, or concerns on how we find the slope or the y-intercept?
What do you 14.6 do?
Actually, we already pretty much did do 14.6.
What, the x-intercept?
Yeah. Look, no, not the x-intercept. Look at this and you'll understand. Sorry about that. You'll understand what I mean by we already
Yeah,
pretty
we
much
just did the
did.
equations for like everything.
It's just like more
This
practice.
is just doing equations.
It's because if I was writing this, I would have not made this chapter so many lessons. I would have just combined things together. But it's because you guys are the accelerated 7 class. We're supposed to be moving quicker. So these are the chapters where we really do move quicker and speed up. All right, I'm going to stop this video and start a new one for 14.6.